Hello, everyone. This is Mary Kurek with Frontrunners Innovate, and I have yet again a familiar face. If you've been paying attention, we have a frontrunner with us, and this is Dr. Nema Khosrow. And Dr. Khosrow is the chair of the Advanced Renewable Power, we call it ARC-Tech, and situated in Indiana. And he's our resident battery expert. And I can say that with total confidence because I know what he has done in his past, and I'm going to let him share a little bit about that in a minute. But our interviewee is Don Turner out of Texas, and he's a CEO of H2Energy Group. And we're focusing on green hydrogen, and we're going to find out a lot more about his background and what he's doing with green hydrogen and H2Energy Group in a few minutes.
One correction, okay. Mary.
Yeah.
You promoted me. I'm Chief Operating Officer.
Operating Officer.
Say,
I'm sorry. Okay, COO of H2Energy Group. So thank you for correcting me. So let's find out about Dr. Nema right now. So Dr. Nema, share a little bit about your background and what you're doing right now with ARC-Tech, and then we'll go on to Don and find out about him.
Well, my background is I got a PhD from Purdue a while ago, and also I've been a professor of mechanical engineering, teaching simulation stuff for quite a while. And also we have a software company, a battery company, and the third one, which you're mentioning here, is Advanced Renewable Power, which builds a mobile power grid. Basically, it's something, if you can visualize, like a refrigerator. You drive it and park it next to your refrigerator at home, and you never have a electric bill anymore. It just generates automatically the energy, and you use it. It's designed for communities. Basically, some people call it nanogrid, some people call it microgrid. That's really what we're doing. And core of technology is the energy storage systems, power conversion systems, power generation systems, the whole bundle of stuff all integrated together. And the goal for that is to really eliminate in the future, similar to what landline, the mobile phone has done for landline, or the Wi-Fi has done for landline, to do for electricity. So there is no transmission line. So this is in summary what we have been working, researching, and doing.
Fantastic. And you've been working in concert with, is it Purdue University there? You're located in that area, correct?
Sure. Yeah. Yes, it's in Indianapolis, and also in collaboration with other companies which are building, battery packs for buses. And I don't know if I should mention those companies or not, but there are several companies that we are working with to generate next generation of batteries and cells, and also the electric vehicles.
Okay, very good. Fantastic, thank you. And Don, you and Dr. Nema share the interesting coincidence, if you will, of having both worked in the same area. So I thought that was interesting that you just shared that right before we went on record. But you're in Texas.
Yeah, apparently we're 200 yards apart and didn't know it.
I know.
Well, yeah, I've moved 24 times. We moved to Texas 2 years ago. I've moved 24 times. So.
Share a little bit about your background, because
witness protection program is going to catch me.
Yeah.
Yeah. Well, my background is really it's really broken up in thirds. First off, my undergrad was General Motors Institute. My engineering thesis is on the esoteric subject of flywheel ring gear processing, and I went to the University of Michigan where I got my MBA. I also completed a master's thesis in advanced computer simulation. We were one of the first companies ever to combine computer simulation with integer programming, so combining optimization with stochastic processes. From there, my background then moved on. I started off in automotive engineering and then went into aerospace for 25 years, was in high tech, and now I'm in energy. 2 years ago, I had to relearn how to spell chemistry, but I'm coming down the curve quickly, hopefully. But I've spent about a third of my career in international strategy work. I worked a little bit with McKinsey. I worked for Booz Allen for a number of years in their technology practice. I've spent about a third of my career in corporate. I've architected and been chief strategy officer of a $1 billion IPO in the CAD industry. And then I've also been group president of a public telecom company where we pioneered unified messaging. And then finally, the last 15 years has really been serial CEO of high-tech companies. everything from artificial intelligence to voice recognition to kiosk, you name it. So I've worked in a broad range of high technology industries, and I was approached about this company a couple of years ago, asked me to come in as Chief Operations and Engineering Officer. And I had known the chairman of the board of this company, Chris Hedrick, who is a real visionary in the green hydrogen space. I've known him since 2016, and he said two questions. One, would you like to join? And two, do you mind moving to Austin? Well, I was already moving to Austin to be closer to my grandkids, so it was providential.
Mm-hmm.
So my background is really characterized by working in engineering and technology intensive industries. Even as a CEO, I tend to work in business places where you really need to understand the technology in order to make effective business and strategy decisions. I love my problem is when I was 29 years old, I was involved in being one of the early kind of pioneers in the advanced computer simulation business, where we took animation technology and combined it to the design of large scale factory automation systems. We were for a while the only ones in the world that could do that. And when you can look in the mirror and say you're the only one that can do something, and you do that when you're young, it's an intoxicating addiction that takes over. You spend the rest of your life trying to push the envelope and trying to do things that other people haven't done before. So that's kind of my background. That's how it's characterized. But I tend to, again, work in a lot of technology, engineering intensive spaces. And for the last few years, I've been working in the green hydrogen space.
Okay. So when they called you to the H2Energy Group table, what did you know about hydrogen as an energy source?
I had known a little bit because they approached me about being the CEO of the company in 2016, and we just couldn't make it happen. So I studied the business, and I knew about it. They had an alternative. About 95% of all hydrogen in the world made is either gray or blue, and that's made from methane, from natural gas. It produces carbon dioxide, and if that carbon dioxide goes up in the air, it's called gray hydrogen. If you capture the carbon dioxide and sequester it at least 800 meters down the ground, it's called blue hydrogen. Only about 5% of the hydrogen in the world made is green hydrogen, and of that 5%, 95+% of it is made via electrolysis. And electrolysis is a great process. We all learned about it in our chemistry labs in high school, where you took a voltage and you put it in water with a anode and a cathode and bubbling, and what was coming out was basically hydrogen and oxygen. We use a different process. We use pyrolysis. We take biomass. So you take any organic object and you heat it up to enough temperature, you gasify it, and you break it up into a different set of compounds. So what we do with our process, H2Energy Group, is we take biomass. It can be tree forest residue. We are at a big focus in California. There's about 144 million dead, down, and diseased trees in California that are creating all kinds of wildfire problems. So that's where our first plant's going to be, and I'll tell you about that in a little bit. But what we do is we take that biomass, we heat it up to 1100 degrees, it gasifies it. We produce a syngas of 65% hydrogen, 18% monoxide, 9% dioxide, 6% methane, a little bit of ethylene. And we do two things with that. One is we send part of that stream into a pressure swing absorbent that filters out and gives us green hydrogen at 5.9 purity, so 99.999% purity. The other thing we do is we operate fully off the grid. We operate behind the meter. We take another part of that syngas and we'll run it through some type of electrical generation system to create electricity for our own plant. So we operate completely off the grid. I love the term nanogrids that Dr. Nema posted a little bit. We work with really electrical grids, microgrids, and we can either have a microgrid just producing electricity or a microgrid that's also producing hydrogen. And our first project is in Red Bluff, California. Our objective is to take the Interstate I-5 Expressway from Carlsbad, California, 1,250 miles north up to Everett, Washington, and help transform that into a hydrogen highway. California is a great place to start because typically their environmental laws are far more stringent than everybody else. They want to get rid of diesel engines, and by 2035, they just a couple weeks ago announced an agreement with all the OEM truck manufacturers to reduce and basically eliminate diesel trucks for the large Class 6, Class 8, 40-ton truck. And the state of California has already concluded that EV technology really is not appropriate for the Class 8. It takes too long to charge. and takes up valuable carrying capacity in the truck. EVs are working great for cars. There's a lot of cars out there, but they've concluded that it's not going to work well for a 40-ton truck. And we're also working on other projects. The largest part of our OpEx is obviously the biomass. So we've really got three companies. We have H2Energy Group, which focuses on producing green hydrogen. We have Net Zero Energy Group, which produces net zero electricity, and both of them use about 80% of all the same equipment. So you can have a company right now working with a European country that needs to have lower cost electricity. They're paying 45 cents a kilowatt hour over there. And we're going to help them provide microgrids to put electricity for various communities. And then when they're ready for green hydrogen, you simply add another couple pieces of equipment and you can produce green hydrogen also. The third company is our biomass development group, where we have the ability to grow our own energy grass, which is a high caloric value, has a high CO2 absorption rate, and really represents a great energy source for us to put into our biomass reactors. So that's what H2Energy Group is doing. It started really in about 2016. The founder of the company, Chris Hedrick, who's the chairman, he's a working chairman and founder, came from the dark side. He came from the coal and the oil and the gas business. And in 2009, he had a revelation and he discovered hydrogen. And he has really helped create the market. Before Chris really got going, there was no green hydrogen market. And now green hydrogen, I think, anybody who's paying attention to the energy marketplace, that is really the hot topic of the day. And everybody's looking at green hydrogen as a power source.
Yeah. Dr. Nema, any questions, comments?
Yes, the way we look at the energy at our system, the mobile power grid, we break it really to four pieces. I just want to make sure I understand where you are fitting at. One is the power generation. Sure. It sounds to me that you guys are in the power generation portion of the business. Am I correct on that?
Power generation for net zero, but also hydrogen fuel for H2Energy Group.
Yeah, but still, let's say in our system, for example, we use solar panels to generate electricity, or the wind turbines to generate electricity. Then we take that electricity, we give it to what we call the power conversion system, so we can massage it and put it in our energy storage system. So there are three things together at the same time. So the generation and the conversion and storage. Then there is a piece of, the big software, we call it the InfiniGrid, to put them all together through the software. So what area are you guys focusing on?
Well, it's actually the first three, because we do generate energy. We generate electricity.
Yes.
We do convert it to a hydrogen fuel, and we do store it. Now, we don't store it as electricity. We store it as hydrogen fuel.
Okay, so you said, now then when you want to use it, you have to reconvert it back into the usable form, give it to the grid, you give it into
No.
Okay. How are you?
No, it probably overseas, we will. It is, as you know, probably far better than I do, sir, it's very difficult to link into US utilities. They don't want you to touch their grid, particularly if you're a competitive offering. Yeah. And we can produce electricity at sub 11 cents, even at 9 cents per kilowatt hour. So if they're just electricity, we'll have an electrical microgrid that's taking the biomass, converting it to a syngas, running it through an electrical generation system, a linear generator, a genset, or a gas turbine, and that's generating electricity. And that runs 24/7, 365, so we can operate as base load, where without storage, solar and wind cannot operate as base load. So if it's simply in the electrical power production, we simply provide the electricity and put it out there, okay? If for other companies, we're going to create a hydrogen fuel for, like, for example, heavy transportation, we will take that part of that syngas, instead of converting electricity, we'll take it out and we'll filter it and pull that 65% hydrogen out and purify it. We store that. We also are looking at right now liquefying it. For gaseous hydrogen, it's not cost effective to ship more than 200 miles, but we have a liquefaction, so we'll cryogenically liquefy the hydrogen, That's how it's stored. That's how it's transported. It goes to a filling station. It's stored as a liquid hydrogen, and then we have a gasifier that puts in, 60 to 80 kilograms of hydrogen gas into that large 18-wheeler. Did I answer your question?
Yes, kind of. So I wanted to say, okay, you have this, let's say like gasoline. You're basically producing something equivalent to gasoline, which is liquid hydrogen. And then there's got to be the engine that also can use that, right? How is the user going to use yours?
The large OEM manufacturers are all looking at PEM technology, permeable membranes. And as you know, the electric motor for an electric vehicle and for a fuel cell electric vehicle is essentially identical. In an electric vehicle, you're obviously getting electricity from a large bank of batteries. In a fuel cell electric vehicle, you're getting it from a tank of hydrogen gas that goes through a PEM, a membrane. The electrons are split out and drive the electric motor. So the actual motor that's driving the vehicle is essentially the same. It's how you're getting electricity, either storing it all as a battery or you're storing it as hydrogen and then converting it to electricity via the PEM.
Okay, so you still to have something in what I classify as power conversion system. You still have to have some device here.
Yes, in the large OEMs, in the
Yeah.
large OEMs, they've almost all gone to hydrogen. They looked at EVs, but for the 40-ton trucks, they have not had good success with it. So most of the large OEMs are going to hydrogen PEM vehicles, fuel cell electric vehicles, as you call it.
Yeah, I understand that. Yes. Well, the evolution of EV also, the cells and stuff like that is changing quite a bit since we started so far ago.
Yes, it is.
Years ago, yeah. It was much more expensive,
Yeah.
much less energy density. Some of the stuff we are working on right now, it will be amazing when it's done.
Well, we see the biggest challenges now. Again, we're actively getting the land ready in California for that first facility, and then we'll have 5 filling stations equal distance along that 1,250-mile route. But what we see as the challenges in hydrogen is, first off, storage and transportation, as you mentioned. You're going to use up about 10% of all the energy content in hydrogen in order to liquefy it. So we prefer not to liquefy it, but if you're going to ship it more than 200 miles right now, that's really the only game in town. You really need to liquefy it. My hope and my belief in studying the marketplace, and I'm certainly not the world's expert in storage and transportation, but I spend half my day every day moving the proverbial green hydrogen ball forward 3 feet. I spend the other half a day talking to people from all over the world that are looking at all kinds of things. And the technology that I believe will replace cryogenic hydrogen in about 4 to 6 years is liquid organic hydrogen carriers. I think the holy grail for hydrogen, one of the tipping points, is to have hydrogen in either a solid or liquid form at ambient temperature and ambient pressure. So that's one challenge. And the second one you've already mentioned is fuel cell. Fuel cells traditionally have used expensive material and been difficult to make, but people are actively working on that and driving the price down. So I think you're going to see the adoption of green hydrogen as a fuel beyond even the Class 8 heavy trucks it's going to rapidly increase as fuel cell prices come down and as we get cheaper ways to store and transport hydrogen.
Okay.
I think what I wanted to go to next on from the standpoint of where you're headed in California and what you're doing, what kind of partners are you putting in place as you work through that process? Because that's quite a big, that's quite a big project that you're putting together there.
Oh, it
will be quite game changing.
It's a $300+ million plan.
Yeah.
Our business model as a company right now is, in order to leverage ourselves and all that, is we have, and this can certainly change and evolve as we go forward. Right now, we look at joint venture relationship where we develop and identify joint venture partners that can bring in relationships from the funding, and we bring in the technology and the operational expertise. In California, we've really been lucky. We have developed a joint venture with a Native American tribal nation called Redding Rancheria, based out of Rancheria, California, or Redding, California, excuse me. and they are absolutely fantastic to work with. The president, Jeremy Hayward, is a visionary. And, it's interesting that tribal nations who have a unique connection to the land may become the leaders in promoting green energy across the country, because we're also talking to other tribal nations about developing this technology. So in California, we got 14 acres in Red Bluff, California, that right now, as I mentioned to you, we're going through the permitting, the environmental studies, site layout and all that, getting it shovel ready. And our senior partner on that is Redding Rancheria, the tribal nation. And then other partners, this is simply, we've decided that we'll only work with the best. We're working with an engineering firm called EPC for H2. That's a firm founded by John Cornish, and it's one of the top hydrogen engineering firms in California. They probably put in half of all the hydrogen filling stations in California. We're also working with Adelante, which is an environmental consulting firm, and working with some other firms, Class Robinson, for doing labor and economic studies. So that's the partners we're looking for. Now, we are having constant discussions almost every day with the various government entities throughout California, at the municipal, at the state, and even at the federal level, looking at partnerships, looking what they're doing. Right now, the Port of Long Beach, Los Angeles, which is the second or maybe the largest port in the world, you cannot drive in a large heavy transport Class 8 truck there that is newer than 2020 without it being a renewable vehicle. And since they haven't had good luck with EVs at that way, and I'm leery to mention anything in the world of electronics with Dr. Nema. I've read his background. He's forgotten more about electrons than I'll ever know. But they won't even allow you into the Port of Long Beach now without a renewable vehicle. They're also looking at now, we're looking at a project where they're thinking about building literally a hydrogen pipeline along Interstate 5, which would be fantastic. And the way that they're going to do that is there's two ways. You cannot just run hydrogen through a natural gas pipeline. Hydrogen tends to make the metal above 20% content of the gas inside the pipe. Mm-hmm. Hydrogen tends to make the metal imbrittle, and it can crack and get voids. And hydrogen being the lightest element in the universe, if you give it a chance to escape, it will escape. In fact, hydrogen and helium will escape, and actually both of them have the ability to escape Earth's atmosphere if they generate enough velocity going up in the air. But they're very light, and about, I think, 14 times lighter than air. But what they're looking at is pipe within a pipe. So they put special pipes that can handle hydrogen inside of a natural gas pipeline that's already existing. That's one way they're looking at it. And obviously another way is to put in a dedicated pipe that is just there for hydrogen. So that's what we're doing in California. As I mentioned to you, we're looking at, we have a European opportunity where, Europe is paying, 45 to 70 cents a kilowatt hour. People are getting, electrical bills of, $1,000 a month. And we can put in a microgrid of 10 megawatts, and we can power 20,000 homes. And so they're looking at putting these electrical microgrids throughout the country. And you can time in then, and when you time in, they'll be able to pass electrical charge back and forth. What we're trying to do is go into the distributed electrical system. I think if you asked any utility electrical engineer today, if you had a blank piece of paper and you wanted to design an electrical grid, nobody would do what they do today, which is build these massive one-shot plants that feed a large area. They build them in distributed areas because it's more resilient, more reliable. And in many ways, it's a lot cheaper in terms of getting the input fuel in there, the energy source that you're converting. So that's kind of the stuff we're working. We're also looking at an opportunity of potentially, north of 100,000 acres in Australia for growing energy, which is our biomass input. So did I answer your California question? I can give you a link later if you want. We actually got we have a cute little 4-minute video done by somebody Andy Greiter and his company. Yeah. They did a little 4-minute video for us that shows the hydrogen highway.
Yeah, we will share that.
Yes, I'll
definitely share that. Yeah. I have one more question, and then I will turn it over to Dr. Nema for any final words. But You said the California plant is going to be your first plant. So this gives us an idea of the status of where you are. You've got a lot of balls up in the air right now with partnerships and different things that you're looking at doing, a lot of projects. What is the most pressing thing that you're looking at right now? What do you need to grow what you're doing to get things moving along, maybe even a little faster than where they are at right now?
I think it comes down to visionary strategic partners with money. How's that? That's the holy grail.
That sounds good.
Funding, right?
Sounds good.
Yeah, but you know, our long-term plan is to have 16 plants throughout the country, and each plant will feed 5 to 7 hydrogen facilities. Initially, it's all geared for heavy transportation. Heavy transportation in California is really a great target, particularly as people are looking at trying to become more environmental friendly. One 18-wheel, 40-ton truck puts the equivalent of about 400 tons of CO2 in the air per year, one truck. If you take a look at the average 10,000 trucks on Interstate 5 at any given day, there's about 7.3 million tons of CO2 being put into the air and as a greenhouse gas. And I, you know, and I don't mean it in a derogatory term, it's just been classification. I've never really been a tree hugger until I got into this, and I realized that, you know, if you take a look at the last million years, yeah, we're at a higher level of CO2 in parts per million by a level of 2 than we have been in the last million years. I don't think that's a natural phenomenon. I think we have something to do with it. And I think reducing greenhouse gases is not only the right thing to do, but it's a smart thing to do. And if you are a grandfather like I am and you have grandkids, it's an obligatory thing.
I hear you for sure. Dr. Nema, any final words?
Sure. Well, Don, I'm interesting. There's so much similarities between what you do and what we do and what we have done. In fact, our simulation company, which is the electromechanical, all structural simulation stuff, all the finite element stuff that we do, thermal modeling, similar to what you guys are doing. Now, on your technology, I understand the electric portion of it, the vehicle portion of it. Let me put it this way: the truck, and then what the needs are.
I'm sure you do.
I understand that part, and I'm clear. On the microgrid, you mentioned that it's very difficult to work with utilities, which I have the same experience too.
In the U.S., it's more open. Yeah. I've got a friend. Yeah, I've got a friend in Germany that he rents space from warehouses and schools and all that, and Germany's more than happy to give him a 20-year contract for him just to feed that electricity into the grid. Feeding the electricity into the grid in California has been difficult.
Yeah, you mentioned the native communities, the same one that some of them that we have talked to as well. Now, in order to provide electricity, not as I said, you have the generation portion, then you have to have. You mentioned that. Then there is the same story. Basically, you provide that kind of fuel. Let's put it in this way: you provide fuel, but they have to have a generator to produce electricity, right? Or you already have. You get this liquid hydrogen. You have.
I'm not sure how cost effective it would be to produce the hydrogen, ship it somewhere, and then use that to produce electricity. I think it'd be a lot more cost effective simply to set up a microgrid. And like I said, we have microgrids that only produce electricity. They don't produce hydrogen. Okay, so they can produce it off the genset. Now, by the way, one thing I want to mention off on the side, since you're a battery expert, is our process produces about 15% of all incoming biomass comes out as biochar. And that biochar, as you know, is not only is an agricultural accelerator, it's a livestock enhancement, but it's also a source for graphene. And a lot of folks are working on graphene battery technology and see if they can get there. But like I said, we can do just a microgrid of just electricity. That's it.
But the microgrid and electricity, somehow you have this hydrogen, you have to give it to something to produce the electricity, or even if you do have the electricity, to be consistent, you have to either store. If you say, okay, we have it 24 hours, we don't have to store it anywhere. It is already in the tank, but still you have to have the network, the house. Are you wiring the houses, the communities your company does it, or you have a partner who does the wiring of the houses? That's a world by
A
itself, right?
partner would do that.
Okay.
Yeah, the development partner would do that. We would put a microgrid in a thing, but relative to the customers and how we're using the green hydrogen, is that will be picked up at our plant by tanker trucks. It'll be taken to the filling stations along that 1,250 mile.
Yeah.
And then that hydrogen, staying as hydrogen, no electrical conversion, will be put into the trucks as a gas. And that's where the electrical conversion takes place through a fuel cell.
So you take that and you produce electricity, but still you have to have at least micro transmission lines, right? Let's say you have how far can you go?
No, once it's on the truck, once the hydrogen's on the truck, it's self-contained. You simply have a 60 to 100 kilogram tank on the truck, and it's doing its own conversion of hydrogen to electricity on that truck.
On the truck, so it's a mobile, but then you
Yes.
have to have cable going through the communities and stuff like that. So there's another distribution network that your partner will
That's
do,
a
right?
separate. That's
So-
for on the electrical side. Yes, you'd have to take the microgrid and hook it into the cabling and the circuits for a community or an industrial park or whatever you're going to power. We're also talking, for example, providing a microgrid to a hospital.
But you don't really build the microgrid. You provide energy into the microgrid. Am I correct on that? Your company doesn't build the
Well,
microgrid.
no, if you look at no, we can actually build the actual microgrid where we have electricity, FOB at our plant, and you hook it into your neighborhood or whatever. We don't build the infrastructure for the neighborhood, but we will put a self-contained microgrid that can produce 5 megawatts to 30 megawatts electricity per, and we can build that as a self-contained unit. Absolutely.
Yeah, the unit
And
is
that's the
still there,
traditional
but that's
definition of
not
a
a macro.
microgrid.
The unit, at least the way we're looking at it, the unit is set, but it's not really a microgrid. You don't have a grid yet. Some partner will build the grid into the houses, right? The grid.
Yeah, this is if you go to microgrid.
You're not doing the
knowledge,
distribute. Yeah,
probably-
you're not doing the distribution. You basically have
We
the
don't do
energy.
the
Somebody else
distribution.
has to do the distribution, right? It's
Yes,
like a
yes.
gasoline. You go get gasoline, right? The people bring the gasoline into the gasoline station, but they do the distribution, right? The partners are doing
Yes.
distribution. Okay.
Yeah.
The
Yeah, we
partner
won't build a
has-
distribution system, but we can have a self-contained facility that's producing electricity, and then you hook it into your neighborhood, your industrial park, whatever that may be.
Yeah, okay. I understand that,
Your
right?
partners.
But
Yeah.
you have to have partners to do that. I'm in the same situation. Like we have mobile power grid. Okay, here we are providing the electricity. This is the box, right? It's on the
Yeah.
truck or
Yes.
whatever form, but we don't actually go to houses and put the lamps and lights and all the other stuff. There's a partner
No.
doing that.
Yeah.
Yep. That's where we've got the same challenge, Dr.
Yeah, yeah. Okay.
Well, fantastic, guys. We need to wrap this up. So I want to say, Don, thank you so much for coming on. This has been an education. I've taken lots of notes, and I actually have a group of somebodies that I think probably would be good for you to connect with as well. Really interesting listening to you talk about the California project that you've got going on that will cement you into the United States, hopefully. And Dr. Nema, always a pleasure. Thank you so much for coming
Thank
on
you.
and sharing a little bit and asking some good questions. So thank you guys very much.
Thank
And
you.
gonna tell everybody that, yeah. Please.
Nice to see you again.
Yeah,
Nice to see you
I
again. It was
appreciate
nice
it.
to meet you. You'll be happy to have partners and
Dr. Nema,
Go
I'd
ahead.
love to sit down with you sometime.
Sure. Then you have my
But
emails, and I'll be more than happy to visit with you in person as well if you're around here.
I've even got your mobile now, so you're
Cool.
already
We have
committed
your
to
number.
talk.
He's the one that
So,
got your number for
but,
me, so I can talk. This is good.
That's cool.
This is
Great.
good. This is how this
Yeah,
works.
I'm still a technology geek. If it's out there, I'll find it. But no, I appreciate it. I'll leave with this thought: is I spent particularly early career with Booz Allen doing technology strategy, where I was forecasting where technology was going 10, 20 years in the future. And I've also done a lot of strategy work. And the essence of strategy is simply to look over the horizon and identify macro trends that you think are real that you want to put capital towards. As I take a look at our energy space, I mean, right now, the state of California could completely double its entire power capacity, and it would make a difference. And I think Dr. Nema would agree with me. Part of the problem in the United States is the distribution system. It's only got so much pipe to it. You can't push any more into it. So, you know, the governor on one day states that we're getting rid of internal combustion engines. On the next day, he states, but oh, by the way, all of you electric car owners, please be more conservative because we're running out of electricity. We can't give you enough electricity to charge your cars. Given that, will there be a green hydrogen gas station at every corner of my lifetime? No. In my grandkids' lifetime, yes. I'm absolutely convinced that green hydrogen is a very, very critical fuel for the future in terms of reducing greenhouse gases.
There you go. Well stated. Well, you're on the path. So let's see what happens. This is good. Thank you again, Don. Thank you so much. Thank you, Dr. Nema. And say goodbye to everybody else.
Nice
My pleasure. Take care.
Thank you. Bye.
So now that you've heard the interview, exactly what did you hear? We tell our business development students and clients and others that we talk to that there are at least 3 opportunities in every business introductory call. You probably are hearing them, but maybe not processing them as the opportunities they could represent for you. Here are the ones that I heard in this interview. Number 1, Don, our interviewee, mentions that the company he's working with is actually getting ready to build a plant in California and is working on a special hydrogen highway project that is involving these big rigs, meaning the big commercial trucks that you see on the highway, semis, I think that they call them. Anyway, so happens I know of a large group of companies that works in the supply chain space that would have their hands on lots of companies with fleets of such trucks, right? I believe an introduction could result in some interesting opportunities, and perhaps maybe you could think of some. Number 2, Don mentions having conversations with government officials in California as they start to set down roots there. If you have contacts that could assist, this might be of real value to him. Number 3, in general, they would appreciate strategic partners who could be involved in green hydrogen projects with them. So think about that. So here's a note to that end. Though Dr. Nema, who was our co-host, is an expert in his area of energy, what he does and what Don does, 2 different things, or 2 different ways of getting to the same result. You can see a potential developing between them for a further conversation. They actually alluded to that in the interview. This lets you know that anyone in the renewable energy space could possibly be a good contact for meeting Don. So think about that. And if you have a good contact, perhaps you should get involved. So if you're interested in learning more about business development or partnering with us, be sure to reach out. And until then, just know that the world needs more front runners like you.